Hello, my name is Jeremy and I'm a product specialist at Abstract, and welcome to this introduction to InstaMAT nPass element graphs. An nPass graph allows you to iterate over the execution of a node graph, providing the previous iteration's result as the input for the next iteration. This iterative functionality allows you to build complex procedural patterns and effects while harnessing the power of the GPU. Today, we're going to walk through the creation of an nPass graph while explaining the basic concepts required and demonstrating a sample of its potential. What we'll be creating is a very basic scattering node with random translation and rotation. We'll also talk about concepts like variables, an image buffer, and what specifically an nPass graph needs in order to persist data for the next iteration. Now, without further ado, let's get started. Okay, so here we are in InstaMAT Studio. Let's go ahead and create a new InstaMAT project, and let's choose nPass element graph. Now, if you'd like to check out the finished graph ahead of time, you can go ahead and click on this scattered tutorial here in the templates and tutorials section. But we're going to go ahead and create a new project without a template. Upon creation, an nPass graph provides two functions, onExecuteAssignment and didExecuteAssignment. OnExecuteAssignment allows you to provide the nPass graph with information stored in its nPass local variables. These nPass local variables are only accessible from within the nPass graph itself. Using nPass local variables, you can store and process information accessible to other nodes within the nPass graph without that information being public. This way, that information is unavailable to the other nodes in the graph where your new nPass node resides. On the other hand, input parameters are public to access from outside the nPass graph. Input parameters are what you adjust in the graph object editor when changing the properties of a node. It's important to note that nPass local variables are different from regular local variables found in graphs such as the atom or element graph. You can tell the difference by noticing the nPass logo on the node itself. Upon the creation of our nPass node, we can automatically assign some information to the first iteration of our program. We can do this by attaching connections to this onExecuteAssignment function. The second function, didExecuteAssignment, is accessed every time a loop or iteration is completed. This is where we have the chance to update the value of our nPass graph's nPass local variables. We'll work with this function later on in the video. If we look at our current list of inputs and nPass local variables, we can see that we have two already, a passCount input and a passIndex local variable. These two are linked together. Think of the passCount input as a way to tell the nPass graph how many times you'd like the program to loop and get its result. Think of it as the sample count parameter in the slope blur node. The slope blur node itself is an nPass graph. So when you increase the sample count, you're actually repeating the slope blur's program to smooth out its result. We can call this passCount input anything we'd like, so that it makes sense to the user from an outside perspective. The passIndex nPass local variable is a way for our nPass graph to understand what iteration number we are currently on, allowing us to perform some logic with it. To access our inputs and nPass local variables in the graph, all we need to do is drag them from the graph object editor into the canvas. So I'll go ahead and drag the passIndex into the canvas and drop it here. Now, what I'd like to do is set the maximum for the passCount, that's our input here, to 64, to limit how many passes we'll be able to do by dragging the slider. We can do this by selecting the passCount input and clicking on the graph variable editor up here, or you can press Shift-2. I'm going to change the range maximum here from 1024 to 64. Now, if we go back to the graph object editor, you can see as I drag the passCount, the maximum here is set to 64. Next, what I'd like to do is generate a set of random numbers for every iteration. We can do this with a random number node. So I'm going to go ahead and right-click to bring up Quick Search, and I'm going to type in random number. And I'm going to choose the random number float node. The random number node allows us to choose a minimum and maximum number, as well as a seed number to base it on. Let's use our passIndex nPass local variable to determine the seed for the random number. So I'll go ahead and connect this to the seed input. Now I'd like to change the minimum and maximum number to go between -1 and 1. This random number will determine the rotation of each image that we are scattering across our texture. In addition, I'm going to need 2 more random numbers for the X and Y values, determining the position of each scattered tile. Instead of creating 2 additional random number float nodes, we can create a random number vec2 node to generate 2 random numbers for the price of 1. So I'll go ahead and right-click again to bring up Quick Search and type in random number, and I'll type in vec2 to create the vec2 node. I'm going to set the minimum and maximum parameters to -0.5 and 0.5 respectively. I'm also going to once again connect the pass index variable to the seed input. Let's quickly talk for a moment about the local seed value of a random number node. The local seed of a node can be found in the Instance Properties section of the Graph Object Editor. What I'm going to do is briefly duplicate this random number float node. I can do this by pressing Command or Control D or holding Alt or Option and left-clicking and dragging. Now here I have 2 identical random number float nodes, both with the same minimum and maximum settings and also the same local seed value of 100. If the local seeds of both random number nodes are the same, then the generated random number will also be the same. You'll notice that here if I change the pass count. As I increase it, you'll see that the resulting numbers of both random number float nodes are exactly the same. When we feed in a number to the separate seed input, the random number will use both the local seed and the value supplied for the seed input to create a unique value. It's important to note that when a new node is created in the canvas, whether it be through Quick Search, the mat library, or through duplication, the local seed will automatically be set as a different random number. To keep ourselves organized, let's create a comment encompassing everything we've done so far. So I'm going to select these nodes. I'm going to hold Shift and left-click and drag to select all of them. And I'm going to press Shift-C to create a new comment. I'm going to name this comment Generate Random Values. Next, let's bring in a node that we're going to provide all of our data for, the Wrap Transform node. This demonstrates how we can bring in many different kinds of nodes into our nPass graph. We aren't just limited to variables and mathematical functions. So I'll go ahead and right-click to bring up Quick Search again, and I'll type in Wrap to find the Wrap Transform node. The Wrap Transform node is like a regular transform node where we can set the rotation, scale, and translation of an image. However, the Wrap Transform node automatically wraps the input across the borders of the image. Next, we're going to need something to transform. Let's supply an image input that the user will be able to provide by creating a new graph input. So to create a new graph input, I'll just click on the canvas here to bring back this area for our Graph Object Editor. And I'll go to the plus button here under Inputs, and let's bring in an element image gray input. I'm going to call it Image by double-clicking here, and then I'll add it to the canvas. You can see that we can adjust the slider here to set a color value, but what I'd like to do is provide a preview image to visualize what we're doing as we work. So I'll go ahead and click the pencil icon, and I'm going to bring in this InstaMAT square grayscale.png. Now let's connect our input to the input of the Wrap Transform node, and we can continue setting the transform parameters. Now let's add some functionality to our node by utilizing our random numbers and creating some more inputs. What I'd like to do is adjust the rotation of each scattered shape, provide a rotation variance so that each tile will have a random rotation based on a range that I give it, and be able to change the scale of all of our tiles. Let's tackle the scale first. First, I need to create a vector2 float input because scale requires an X and Y value. The quickest way to do this is through Quick Search by way of the Wrap Transform node. First, we need to expand the available inputs for the node itself. Next, we can drag a connection off of the scale input and let go to bring up quick search. We can then choose to expose scale as graph input. You can see how using quick search, we saved a couple of clicks instead of going to the input section of the graph object editor. It also automatically sets the graph input to the correct type. In this case, the wrap transform node is looking for a vector2 float value type denoted by the light pink graph connection point. I'm going to set our scale input to default to 0.25 for both the X and Y. So I'll go ahead and change it here in the graph object editor, 0.25, and I can use this little lock icon here to make sure that both of these always match. I also want to change the range maximums, so I'll go ahead and make sure that I have my variable selected, go to the graph variable editor, and I'm going to change the maximum here to 0.5. Now, you'll also notice that InstaMAT has automatically put a category here called transform and assigned it to our graph input. In this case, I'm just going to remove it and leave it blank. Now let's go to the graph object editor and we can adjust the scale parameter. Now let's take advantage of our random number vec2 that we created earlier, as well as our scale input to generate a random position for each of our scattered images. I'm going to go ahead and make some room here. And let's see what happens if we connect the result from the random number vec2 directly to the translate input of the wrap transform node. I'll go ahead and adjust the pass count. Now notice that as we change the pass count, the image only randomizes its position within a small area. Let's expand that area by dividing our vector2 for the translation by our scale graph input. Now, another way to add nodes is by right-clicking the connection to bring up quick search. So I'll right-click it here, and I'm going to type in the divide key or the slash here, and you can see that we get the vector2 divided by float or vector2 divided by vector2. So I'll go ahead and use this one here and double click it to bring it in, and you'll notice that quick search automatically makes our connections for us. Now what I'm also going to do is create another instance of our scale graph input. So I'll go ahead and drag one in here, and I'm going to connect it to the B input of the vector2 divided by vector2 node. Now as I change the pass count, the image will randomize its position with a wider area of opportunity. We're going to take some similar steps towards setting and randomizing the rotation. Again, I'm just going to make some more room. So now what I need to do is create a rotation parameter. So let's go ahead and do that by going back up to inputs, clicking the plus button, and I'll type in float. And let's create a new float32 graph input. I'll double click it to name it rotation. Notice how our rotation parameter is using a spin box control by default. Let's change it to a vector angular control. We can do that by right-clicking the parameter here in the graph object editor and go down to change UI control type to, and let's choose vector angular. You'll notice that the widget changes here, and if we right-click it, you can now see we get this larger circular widget where we can adjust the angle very easily. Let's do the same for a rotation variance parameter that will tell our nPass graph how much it can randomly rotate each tile for each iteration. So again, I'll hit the plus button, type in float, press enter to bring in a float32, and let's rename this to rotation variance. And I'll go ahead and double click here so that we can resize everything to see the full names of our inputs. So let's go ahead and bring in both of our input parameters here, both rotation and rotation variance. And what I want to do is multiply the rotation variance by this random number float node that we haven't used yet. So I'll bring off a connection here from random number float, and I'll just type in the asterisk or the star and press enter to bring in a float times float node. Now I'll connect my rotation variance input to the B input of float times float to multiply this variance value by the random number that we're generating. Now what I'd like to do is add our rotation value to the result of this multiplication. This makes it so that no matter what the value is, our tile will always rotate by this certain amount every time. So I'll go ahead and just make sure I stay organized and leave some space, and I'll just branch off a connection from the float times float and press the plus key. I'll bring in the float plus float node here, and now all I need to do is add this rotation value by supplying it as the B input of the float plus float node. Now all that's left to do is connect the result of this to the rotate input of the wrap transform. Now I just noticed here what I need to do is change this rotation variance from the default spin box to the different widget. So I'll go ahead and right click it and choose change UI control type to vector angular again. And let's go ahead and apply some variance. So we can increase it here, but I think what I'm going to do is just apply a little bit of variance for now. Now, if I go ahead and increase the pass count, you can see that the InstaMAT icon is getting a random rotation after every pass. I can also change the rotation here, and we can set that initial rotation value. And that's all the logic we need for our wrap transform node. Let's go ahead and create another comment and make sure that we stay organized. So again, I'll hold shift and left click and drag to select all the nodes. And now instead of pressing shift C, you can also right click one of the nodes and choose comment. So I'll go ahead and adjust the size of this comment. And I'm going to call it set up our random scatter transform. The last two things we need to do are create our image buffer and set the output for our new node. The image buffer is what will persist over each iteration, allowing our nPass graph to blend these scattered shapes on top of one another. Let's start by creating the buffer nPass local variable. We're making it a local nPass variable because we don't want the user to be able to access the buffer directly. So I'll click on our graph, go to nPass variables, and add a local variable. In this case, we want to add an element image gray. I'll go ahead and call it buffer, and I'll bring it into the canvas. Now what we need to do is blend our buffer with the first iteration, and we're going to be using a maximum blending mode to do this. So I'll right click, type in blend to bring in a blend node, and I'm going to connect the output of our wrap transform to the foreground of the blend. I'm then going to connect the buffer to the background of the blend node. And then finally, what I need to do is set the blend mode from default to maximum. Now, in order to get this to work, we have to assign the output of the blend so that it's stored in the buffer nPass local variable every time the graph executes. And this is where that did execute assignment function comes in handy. So let's go ahead and find that function. There it is, did execute assignment. And you'll notice we now have a buffer input, which matches our buffer nPass local variable that we created. So all I have to do is connect the output of the blend node to the buffer input. And so after every execution, as you can see here, we're now going to assign this blend to the buffer. Now, every time the graph iterates, the buffer is going to be set as the background of our blend node, and the randomized shape will be blended with it with the maximum blending mode. And after each iteration, the result of this blend will be set as our buffer, and the cycle continues. You'll notice that we can start to see this behavior by adjusting the pass count. Finally, let's create a graph output so that our result can be retrieved and used by other nodes. We can do this by using quick search. So I'll go ahead and drag a connection off of the output of the blend node and choose expose output as graph output. And that's everything we need to do to create our new scatter node. So let's quickly review what we've done to create our scatter node. To begin, we started generating a few random number values. Each time our pass index increases, a new random number is generated. We then used those random numbers to set the rotation, scale, and translation of our input image using the wrap transform node. We then created a buffer nPass local variable and blended our transformed image with the buffer using a maximum blend mode. The results are then stored in the buffer for the next iteration. Finally, we created a graph output to pass our scattered image data to other nodes. Now let's go ahead and test out our new node in a new graph. Let's first give this graph a name. So I'll go ahead and click this here, and let's call this Simple Scatter. I'll go ahead and save this. And so I'll click the plus button here to create a new project. I'll choose Element Graph and create a project without a template. And I'll just drag our Simple Scatter from the Package Management panel into the canvas. So now I'm going to supply a different image as our input, and in this case, I'll just use one of the built-in nodes into InstaMAT. I'm going to use the Awesome Shape Generator node, which allows us to select many awesome glyphs that we can use for any of our projects or materials. In this case, I'm just going to stick here with the element icon. So I'll just connect this to the image input of our Simple Scatter, and you can now see that we are scattering our Awesome Shape Generator's output here. So I can go over here to the pass count and increase it to scatter our input image. And now we can see our Simple Scatter node working. I can also adjust the scale and the rotation and rotation variance. So let's go ahead and crank this all the way up. And then I can also set up that initial rotation as well. Thanks for watching this quick introduction to nPass graphs. While we've covered a bunch of concepts including graph inputs, nPass local variables, image buffers, value types, and mathematical expressions, there's a lot more to uncover. If you'd like to take this further, try taking what we've learned and create some variances for the luminance and scale of each tile. nPass graphs can be used to build complex systems ranging from particle simulations to mesh modifiers. While we used an image buffer in this example, the nPass element graph is not limited in the kind of data that can be persisted across the execution boundaries. This can include mesh data, strings, and much more. Now, if you'd like to learn more about nPass element graphs and the other project types within InstaMAT Studio, subscribe to our YouTube channel. Here we have an ever-expanding library of videos covering the ins and outs of InstaMAT. Well, that's it for now. Thanks for watching, and we'll see you in the next video. If you enjoyed this video, drop us a comment below, and don't forget to subscribe. For the latest news about InstaMAT, please visit our website and follow us on Twitter. You can find all the links in the video description below. Thanks for tuning in, and we'll see you in the next one.